Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 9 from the June 2023 Pure Mathematics P1 International A-Level Edexcel paper. And this question here is about trig graphs and their transformations. So it says figure 3 shows part of the graph of the trig function with the equation y equals f of x. So part A says write down an expression for f of x. So just by looking at this graph, we can see that it is of the basic shape of the cosine curve. Okay, we should know the basic shapes of the sine and cosine and tan curves. So the sine curve between 0 and 360 or 0 and 2 pi has this type of shape, something like this. And the cosine curve between 0 and 2 pi has this type of shape like this, which is, well, not very well drawn, but it's similar to this type of shape here. Okay, but the cosine curve, its maximum occurs at 1, its minimum at -1. In this case, the maximum is 3 and the minimum is -3. The cosine curve, y equals cosine x, hits the x-axis at pi over 2 and 3 pi over 2, and this looks like it's hitting in the same two places, halfway between 0 and pi, and halfway between pi and 2 pi. So it looks like that, in terms of the x coordinates, everything's the same. Okay, it's got the maximum 0, 1 here, it's maximum 0, 3. Here at pi and -1, so at pi there's the minimum here as well. So we see that they're the same except for the y-axis. Okay, so in terms of the x coordinates, everything is the same. Okay, like if I was to write out the minimum point of for y equals cosine x, the maximum point, the first one here, that would give you 0 and 1. This is 0 and 3. Over here we have pi over 2 and 0. Here we have pi over 2 and 0. Okay, they're the same in the ones on the x-axis. This would be pi and -1. Now it's pi and -3. Okay, so we can see that the cosine curve has been stretched vertically by a factor of 3. All the y coordinates are multiplied by 3 and all the x coordinates remain as they are. So for example, if I look at y equals cosine x, okay, we have 0, 1, and that became 0, 3. Let's start from the first coordinates over here. Okay, you have -2 pi, you have -2 pi and 1. Okay, as you can see in this has become -2 pi and 3, right? And you have, for example, here -3 pi over 2 and 0, -3 pi over 2 and 0 stayed -3 pi over 2 and 0. On the cosine curve at -pi, you would have -1. But here we see we've got -pi and -3. Okay, at -pi over 2, you would normally have -pi over 2, 0, and this is still -pi over 2, 0. So it looks like the x coordinates are all the same. Okay, but the y coordinates have been multiplied by 3. So if there's 0, it didn't change, because multiplying by 3 doesn't make any difference. So -1 became -3, 1 became 3, and so on. And the same would continue on. You see we got when x is 0, y is 1 on the cosine curve normally. Now it's become 0 and 3. And the rest will be the same except just positive. So we can see that everything has been stretched by a factor of 3 vertically. So this is going to be y equals 3 times f of x. Okay, so it says write down an expression for f of x. So we can say f of x is going to be equal to, well, not 3 times f of x, let's call it. This will be 3 times cosine x. Okay, so let's write something different. Okay, so for example, if we can say that the normal cosine curve, this one, is y equals g of x. We can say f of x, okay, y equals f of x is equal to 3 times g of x. Okay, 3 times g of x. So we can say 3 times cosine x. All right, now it says sketch for minus 2 pi to 2 pi the graph of the curve with the equation y equals f of x plus pi over 4. So here we have a change taking place inside the function. As we saw here, this was something taking place outside the function. You multiplied the original function by 3, so it ended up being a vertical stretch of factor 3. A vertical stretch of factor 3. Anything that's affecting outside the function, multiplying the whole function, added to the whole function, subtracted from the whole function, affects vertical transformations. So multiplication causes a stretch of factor 3. Addition, if it was, for example, y equals, if this question said f of x plus pi over 4, that would mean a vertical translation of pi over 4 upwards. But if it's inside the function, it becomes a horizontal transformation. And if it's inside the function, it kind of does the opposite. So instead of this being a translation of pi over 4 like to the right, it's going to be to the left. You do the opposite of what the sign says. So this is actually a translation of minus pi over 4 as a vector minus pi over 4, 0. You're going to take all the x coordinates and subtract pi over 4 from them, and the y coordinates will remain the same. So if we look at the original curve like this, okay, this is y equals f of x. Okay, this is the original curve. Okay, if we're going to draw y equals f of x plus pi over 4, all the y coordinates will remain the same. Okay, so they'll still be the same, like, shape of this graph in terms of its amplitude, how its maximums. They'll still be the same values, but the x coordinates will shift. So instead of it being, everything will go back by pi over 4. So this 2 pi will end up being up here somewhere. Let me just make that thinner. Okay, so the 2 pi will end up being a quarter. So that's pi. I mean, this is like, each of these is half pi. So this is pi over 2 plus pi over 2. So a quarter pi is a half of this. So about there, okay, which is going to be halfway between 2 pi and this is 3 pi over 2, halfway between them. Okay, you're going to have this point going over here. So all of these points now will be points which are important for us, halfway between these. Okay, so for example, this is pi over 4. And this is going to be pi over 2 plus pi over 4, which is pi over 2, which is 2 pi over 4 plus pi over 4, that's 3 pi over 4. And this is going to be plus another pi over 2. So you got pi over 4, 3 pi over 4, this would be 5 pi over 4. You're going to keep adding 2's. So 5 pi over 4, and this is going to be 7 pi over 4. Okay, so this is going to go back here. This point is going to be over here, so it's going to go through these points here. Okay, and this minimum here is going to go back down to where this is. It's going to go back here. Okay, and this point is going to go to here. This point is going to go, and again, you're going to have the same things on this side. You're going to go to halfway between each of these. So this would be minus pi over 4, minus 3 pi over 4, minus 5 pi over 4, and minus 7 pi over 4. So this point's going to go back to here. This point's going to go back to there. Okay, this point is going to go back to here. This point's going to go back to there. And this point is going to go out of range. We have to draw between minus 2 pi and pi. Minus 2 pi and plus 2 pi. So basically what's going to happen is the whole graph is going to shift to the left by pi over 4. Okay, so I've just physically shifted it, right? It was like this. I've drawn it in such a way so I can shift it. Unfortunately, in an exam, you can't do what I just did, right? You have to actually draw it, of course. Okay, I did a bit of a cheat there. But basically, that's what's happening. It's shifting by pi over 4 to the left. Okay? So it says, show clearly the coordinates of all the points of the curve intersect the coordinate axis. So let's see, is this actually going to be 2? Make sure. For all of these, we've got the points here. So I'm going to write them out a bit more clearly because it's a bit of a mess there. You can't see very clearly what I've written. So I'll write those points down clearly now. Okay. So it's going to be basically, as we mentioned, so that's minus pi over 4. That's going to be minus 3 pi over 4. And that's going to be, there's a minus 5 pi over 4, minus 7 pi over 4, just before 2 pi, minus 7 pi over 4. And here you're going to have, this is going to be a pi over 4. Okay, that's going to be pi over 4, 2 pi over 4, that will be 3 pi over 4. Okay, and here you're going to have, it's going to reach this top part here at 5 pi over 4. And then it's going to continue going down like this. So it will continue a little bit over there. Because we've got to draw it all the way to 2 pi. So let's just draw that bar there. It drops down a bit until it reaches 2 pi. Now, we're going to also have to work out what point, is this actually going to be 2? Let's see. We can work out what this point is when x is 0. When x is 0, we have y equals, and this is going to be 3 times cosine of x plus pi over 4. Now, when x is 0, you have y equals 3 times the cosine of pi over 4. And so that gives you 3 times, and this is going to be root 2 over 2. So 3 root 2 over 2, which is not exactly 2, is it? Okay, so let's see what that gives us. 3 times root 2 over 2. That gives us 2.12. So it's just over 2, actually. So this point here is just above 2. So what I'll do is just put it this side. Slightly adjust it a little bit. So so I'll put here 2 root 3 over 2. Sorry, 3 root 2 over 2. What I'm talking about. Okay, so that's 3 root 2 over 2. 3 root 2 over 2. That is the point where it hits the y-axis. So these are the points where it hits the x-axis. These are the minimum points here. And that's the point where it hits the y-axis. Okay, so that's the sketch of this curve. I've kind of cheated a bit by taking the original, tracing the original and just moving it along. I guess you guys could do a bit of a tracing if you wanted to. If you had tracing paper and then do it as well, it would, I guess it would be okay. But yeah, anyway, so that's that curve done. But the important things are for you to have the points where it hits the x-axis and the y-axis noted. And this curve should stop actually over here. Okay, it should stop at minus 2 pi. So it's, whoops. Let me just do this. So it should go up to about there. Okay, it stops at minus 2 pi. Okay, and here it continues until 2 pi. All right, so there's 3 marks for that. I think this question is one of those questions that will take a bit of time. All right, so you got to be a bit careful with timing. I don't know why they gave such a long question, because there's another sketch you've got to do as well here. So it says here we have the part of the graph of the trig function with the equation y equals g of x. All right, so now in this case here, we got to write down the expression for g of x. So as I mentioned in the beginning, that the sine curve has this shape between 0 and 2 pi. And this has a similar type of shape, except it's like repeated. So it's kind of like related to the sine curve, but we can see that it's the sine curve would look something like that. It would go to highest as 1 and lowest as -1. So vertically it's the same values, but it's like you can fit two of them in one. Normally the sine curve, your pi would be your maximum, and for this, pi over 2 would be your maximum, and it would go like this, and that pi would be 0, and that minus 3 pi over 2 would be a minimum, and then 2 pi, it will be 0 again. So this should be a bit over there. But basically, we can see what's happened is that there's two of them fitting in one. Okay, there's two of them fitting in one. So its period has been halved. The period of this curve has been halved. The period of the sine curve is normally 2 pi. The period of this curve is pi. Okay, so what's happened basically is you've had a vertical stretch of factor a half. Okay, vertical stretch of factor of half. Sorry, a horizontal stretch, of factor of a half. So a horizontal stretch of factor of a half means that all the x coordinates have been halved. So what was 0, 0 stayed 0, 0. Okay, what was originally pi over 2, 1. Okay, the x coordinates being halved, it became pi over 4 and 1. So this is now pi over 4. Okay, and what was originally pi and 0 became pi over 2 and 0, and so on. Okay, so everything's been halved. What was originally 2 pi 0 became pi and 0. Okay, so every x coordinate has been halved. So that's going to take the form of y equals, it's going to be cosine of, in brackets, 2x. So sine of 2x. When you have a horizontal stretch of factor of half, it's going to be something like that, f of 2x. So this is going to be like when you multiply the x coordinates by a half, by the reciprocal of what's inside here. Okay, this is a horizontal because it's inside the function, and it's kind of like the opposite. So if you have 2 times x inside the function, it means you're multiplying by the reciprocal of that 2, which is a half, because it's inside the function. So this is y equals sine of 2x. Okay, that's the answer to question 9, part 2. And then it says for part B, 2a, this is part, it says on a separate diagram, sketch for x between -2 pi and 2 pi, the graph of the equation y equals g over x minus 2. So we're going to take this graph, and we've got to basically do a vertical translation of factor 2. So if you're adding something outside the function, it's going to be a vertical translation, and because it's outside the function, it acts normal. So this is going to be basically a translation of 0 minus 2. Translation of 0 minus 2, everything moves down by 2 spaces. Okay? So all of these points will remain in the same place, except they everything moves down by 2. And it says show clearly the coordinates of the y-intercept. Okay? So the y-intercept is going to be down at -2. The whole thing is going to shift 2 spaces down. So let me get that sorted out. Okay, so for us to do this translation of 2 units down, we take the original curve, which, as we said, the original curve was y equals sine of 2x, which is what's drawn here at the moment, and that becomes y equals the sine of 2x minus 2. Okay, where you subtract 2 from the whole function. Okay, this is what this transformation represents. Okay, so that's going to be where the whole thing goes down by 2 units. Okay, so basically what happens here, at the moment this is +1 here, and that's -1. Okay, so these points all go 2 units down. So these maximums go down to -1, and the minimums go down to -3. Okay, so the whole thing shifts down 2 units. Okay, but the x coordinates stay the same. The y coordinates are now shifted down 2 units. Okay. So what was over there, that becomes 0 minus 2. Okay, so the maximum that was 1 becomes now minus 1. Okay, so at that point here, okay, so this is now, this is minus 1 here. So those are the maximum. The minimums are at minus 3. And it hits the x-axis, or the y-axis at minus 2. Okay, the question tells us to write down the coordinates of the y-intercept. So it's just minus 2 here. So the whole thing just shifts down 2 units. Okay, so the y-intercept here is going to be 0 minus 2. That's the y-intercept. Okay, so that's this graph. If you were going to draw it by hand, it's going to take you a bit of time and probably be messy. Okay, I did a little cheat there. I just traced it, did it. And there we got our answer. So there's the answer to part B. Okay, so y equals sine 2x. Okay, that's it. I think that's question 9, part 2. And that's the end of the question, I think. Okay, so that concludes this question. Other questions from this particular paper, the June 2023 Pure Mathematics P1 Edexcel paper, can be found in the playlist that will appear in this region over here. Other questions from the topic of trig functions or trig graphs and can be found in the playlist that will appear over in this section over here. Other questions from the topic of transformations of graphs you can find in the playlist that will appear in this region, and you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.